Hi, I'm Amir Hossein Mirza Bozorg, and in this video I want to talk about meshing and partitioning 3D solids in Abaqus by using tetrahedral elements. This is the table of content. I will talk about kinds of tet elements according to their order. Example 1, how to mesh a propelling system by using second order tet elements. And example 2, meshing and partitioning a complex geometry in oil industry for exact calculation of stress concentration. Most of the time, especially in industrial projects, we are faced with complex solid geometries that must be meshed and then analyzed. At first, we should try to partition them in order to create hex elements on the geometry. After doing trial and error, if we are not able to create hex elements on the geometry, the only choice is using tet or tetrahedral elements for meshing the geometry. In this video, some aspects of creating tet elements are explained for creating high quality elements and finally get the exact results. Actually, the most accurate simulation can be performed by using hex elements. But in most of the industrial projects, because of the complexity of the geometry, we cannot use hex elements. So the only choice is the use of tetrahedral elements. And in this video, I want to talk about how to increase the accuracy of the simulation if we use tetrahedral elements. Now I want to talk about kinds of tet elements according to their order. We have two kinds of tet elements in the Abaqus mesh module. First order tetrahedral element and second order tetrahedral element. About the first order tetrahedral elements, shape functions in this kind of element is first order. This leads to constant strains in each element domain that causes large errors. So if you want to use this element, you must use a very fine mesh in your model. In Abaqus documentations, the use of this element is not suggested at all. And about second order element, shape functions in this kind of element is second order. This leads to less error in comparison with use of first order tet element. In Abaqus documentations, the use of this element is recommended in domains that hex elements cannot be used, like the complex geometry. Always the C3D10M element is the best choice. In some cases like XFEM, you are not allowed to use C3D10M element in the enrichment zone. So you must use C3D10 element. C3D10M element is modified second order tet element and C3D10 is the simple second order tet element. C3D10M element is available in both of the Abaqus standard and Abaqus explicit solvers. Actually, it is the only available second order element in the Abaqus explicit elements library. It has a better performance than C3D10 element. Now I want to talk about example 1, how to mesh a propelling system by using second order tet elements. Here you can see the geometry of the propelling system. It is too complex to be meshed with hex elements, so we must use tetrahedral elements. I have the step file of this geometry and I will import it to the Abaqus mesh module. When we import the geometry, we will face this warning and I will talk about this warning in the Abaqus. Now I want to import the geometry to the part module. File, import, part. I choose step and I select the file. Here we have this warning. I will talk about the warning in the slides. In importing most of the complex industrial geometries to Abaqus part module, we will face this warning. This warning says that medial axis meshing algorithm cannot be used for meshing these geometries. Most of the times we can mesh these geometries by using tet elements, but in some cases even they cannot be meshed by using tet elements in Abaqus mesh module. So we must use the hypermesh software. Actually, this warning does not say that your CAD file has problem or it is corrupted. This warning means that your CAD file is complex and cannot be meshed or partitioned easily. But in most of the cases, we can mesh the geometry by using tetrahedral elements. But in some cases, because of the more complexity, we cannot mesh the geometry by using the tetrahedral elements in Abaqus mesh module, and we must use hypermesh software. When you import the geometry to the Abaqus mesh module, the color of the part will change to orange. That means that it cannot be meshed by using a structure technique or sweep technique. And the only choice is the use of free technique and tetrahedral elements. If you want to use tetrahedral elements for meshing 3D solids, in the mesh controls, you must select TET. And free technique is selected automatically. And here we have the settings of free technique. The most important setting in this section is this setting. Use map try meshing on boundary faces where appropriate. If you activate this setting, Abaqus tries to use mapped triangles in all of the regions of the selected geometry. But if you deactivate this setting, Abaqus will not try to use mapped triangles in all of the regions of the geometry. I will talk about this setting in the second example too. And here I have selected quadratic from geometric order and I have selected modified formulation. So the geometry will be meshed by using C3D10M elements. And finally we will get this mesh. I go to mesh module. Here mapped triangles are used and here unmapped triangles are used. At first Abaqus tries to use mapped triangles in all of the regions, and in some regions it is successful and in some of the regions it is not successful. Here it is not successful and here it was successful. Now I want to talk about example 2, meshing and partitioning a complex geometry in oil industry for exact calculation of stress concentration. Here we have a hollow cylinder and at the middle of the cylinder there are a lot of grooves. And we want to calculate the stress concentration at the tip of one of the grooves. This is the target groove. And here you can see its geometry and this is the groove's tip. Because of the limitation in physical memory and simulation time, the number of elements must be optimized. So we use small elements at the one of the groove's tips. For having complete control over the element size, several partitions have been created. Here you can see the partitions. I have used datum planes for creating the partitions, and this is the selected groove, this one. And I have used tetrahedral elements for meshing this geometry. And in these regions that are far from the stress concentration region, I have used larger elements, and here I have used smaller elements for accurate calculation of stress contour. Here you can see that as we get closer to the tip of the groove, I have used smaller elements. And at these regions, mapped triangles are used, and in these regions, unmapped triangles are used. And at the tip of the groove, we have the smallest elements in the geometry. And this is the stress contour, and here you can see the stress concentration. This is the hollow cylinder. This is the selected groove. And here you can see the decrease of element size. Always we must do like this for optimizing the size of model and decrease the number of elements. Here the stress concentration can be calculated accurately. You can contact me by using Telegram or WhatsApp, and you can send email to me. We can have one-on-one tutoring on the AnyDesk or WhatsApp, and we can make special videos to your order. We can perform high-quality simulations for your physics exercises and industrial projects. Thank you so much for watching this video. Goodbye.